A SAM project file contains one or more cases. SAM's title bar displays the project file's name and the software version number. Tabs along the top of the main window provide access to the cases in the project, similar to the tabs along the bottom of an Excel workbook that provide access to worksheets. Including multiple cases in a project file is one way to compare different analysis scenarios in SAM. You can compare different financing scenarios, as here, where we compare photovoltaic systems for residential, commercial, and utility scale applications. You can also use cases to compare different technologies. For example, these two cases compare flat plate and concentrating photovoltaics for a utility scale project. You could also compare a photovoltaic system to a parabolic trough system or other solar thermal technology. Because SAM includes different options for modeling the same system components, you can also use cases to compare results for the same system based on different models. These two cases both model the same residential system, but one uses the Sandia module and inverter models, while the other uses the PV Watt system model. The Case menu is where you'll find commands to add, rename, copy, and delete cases from your project file. SAM's navigation menu provides access to the input pages. On this page, we see a summary of the system. The Climate page offers several options for defining the solar resource at your project's location. For example, you can choose a location from a list or type an address to download data for any location in the United States. Other pages give you access to financing and incentives inputs, where you can type values and choose options to define the financial parameters of your project. The Costs page is where you specify the project's installation and operating costs. You can enter costs in different units, and SAM calculates total costs displayed here in blue. You can specify operating costs as a single annual value, or assign costs to specific years. Wherever you see the blue and gray button near an input variable, you have the option to assign a value to each year in the analysis period. The component input pages allow you to describe the parts of your system and give you modeling options. Here, the Inverter page offers two options for modeling inverters, including an option to choose from a list of commercially available inverters. The Array input page allows you to specify the size of the system and the array orientation. The other technologies have analogous input pages. For example, here's where you specify the parabolic trough model's receiver characteristics. To run simulations, click the Run button with the green arrow in the bottom left of the window. SAM shows the status of the simulation in the status bar. When the simulation run is finished, SAM displays the results page. The metrics table displays a summary of the results. You can display up to 4 graphs on the results page by clicking the graph thumbnails. To display more than one graph, hold down the Control key while clicking the thumbnails. We just saw results for a single simulation. SAM offers several options for configuring simulations for more complex analyses that require more than one run. The Configure Simulations button displays the simulation configuration page where you can configure runs for parametric, sensitivity, optimization, and other analyses. I'll use the parametric option to create a graph of total annual output versus array tilt for a photovoltaic system. I'll start on the Simulation Options page to assign the tilt variable a range of 7 values from 0 to 90 degrees. When I click Run, SAM runs 7 simulations, or 1 for each tilt value. After running simulations, SAM displays a bar graph of annual output versus tilt. A line graph would be clearer, so I'll double-click the graph's thumbnail to edit its properties and change it to a line graph. You can also configure simulations with multiple parametric variables. In this final clip, I'll demonstrate how to set up a parametric analysis on both array tilt and azimuth, and how to display a contour graph showing how varying both variables affects the system's electrical output.